Hi, I'm Lee Teschler with EE World and Design World. I'm here with Dan Carnevale from Eaton's Experience Center in Pittsburgh. What we have behind us is a little simulation of a substation as might serve the electrical needs of a residential suburb. What we're going to talk about is what happens when a lot of houses in a suburb have solar power. When one or two houses have solar panels and send power back to the substation, no problem. But as more and more houses generate their own power and send it back, it causes problems at the substation that may limit the amount of power that the suburb can generate. But Dan, exactly what's the problem when you get a whole lot of power coming back the wrong way?
That's a good question, Lee. So what happens is basically you have, the utility wants to send power from kind of a high level, from a voltage level, down to the load, and it drops along the way. What happens when you install solar and large bulk, sections of solar, so whether it's many homes or a large, say, commercial or industrial application where there's solar, they actually kind of end up putting power into the substation. So back here at our transformer, our voltage actually goes up, and then it goes back down to the load. So what happens is these things that we're standing right next to are regulators, and the regulators get a little bit confused. Do I need to go back up or do I need to go back down? And then a cloud comes by and the solar goes away and the regulators are low and the voltage is all over the place. So we have issues with three main components. One are the capacitor banks that supply the reactive power to kind of maintain that voltage stabilization. The other thing are the regulators that truly regulate the voltage. And then the third thing is really the capacity of the transformers and the other equipment, the wire sizes and so forth. The more we put into the substation, they're rated for a certain amount of current. We may put more current in than they were even rated for.
So what do you do?
Well, so what they do is it's more around control, and it's more around actually changing the way the regulation is done, and it's maybe sizing the capacitor banks a little bit differently. And for large solar installations, sometimes they use those instead of the capacitor banks to regulate the reactive power flow. And so it's really a coordination of efforts. It's not just allowing it to kind of happen, it's actually coordinating all those efforts, working with the control, and making sure the equipment's sized correctly.
I see. Now this regulator, we can actually show what happens when that occurs. Can we do that?
Yeah, let me show you how it works. So there's a manual control here, and there's obviously a remote control, and you can see this thing is called a tap changer. So inside there, I'm changing the taps, and I can go plus or minus 10%. So for example, if the solar pushes the power into the system and the voltage goes up, the regulator can back off and reduce the voltage to the load, but does that automatically. And if the solar kind of goes away because there's a cloud, the voltage can go back up. So we can continuously monitor and regulate that. But these guys have to be coordinated with those systems to know how to make sure that they're doing it right. And they frankly don't operate super fast. So you have to anticipate a little bit of that so that you don't go too far one way or too far the other way and end up with too high a voltage or too low of a voltage.
Yeah, interesting problem to have for the utilities.
Sure is. So substation design is an important piece, and it's all about coordinating those efforts of the utility companies and large solar installations across the grid.
Okay, interesting. Thanks.
Thanks very much.